In this lesson, we are going to learn how to simplify powers that have the same base using the product rule. We'll also discover how to simplify powers of the same base using the quotient rule. So let's get started. So in our example number 1, we can see that we have x squared times x to the third. So we are multiplying these powers that have the same base. So we're going to show the rule by first expanding what this means. So x squared is simply x times x. Then we're multiplying that times x cubed, which is x times x times x. So when we put this back together as one base, we really have x to the 1, 2, 3, 4, 5, x to the fifth. Example number 2. 7 to the third is really 7 times 7 times 7, and then it's being multiplied by 7 to the fourth, which is simply 7 times 7 times 7 times 7. And then when we rewrite this expression with the base of 7, it's really 7 to the 1, 2, 3, 4, 5, 6, 7. We're only simplifying here. We're not going to evaluate that. Number 3, k to the third is simply k times k times k. Then it's been multiplied by k squared, which is k times k, times k. So when we rewrite this expansion as one base, we have k to the 1, 2, 3, 4, 5, 6. So you may be seeing a pattern of a quick rule, but let's try one more. We have -3. The negative is included as the base, so we have -3 squared times -3 squared. We're going to expand the negative, so -3 squared is -3 times -3, and then it's being multiplied by another -3 to the second. And we really have -3, and it's super important that you make sure if the negative is part of your base, then you include it by using parentheses. So we have -3 raised to the 1, 2, 3, 4. So let's look to see if we see a pattern happening here. X to the fifth, you can see that we had 2 x's being multiplied, and then it's multiplied by 3 more. So we just added the exponents. Here you can see 3 plus 3 is 4, and we got 7 to the seventh. Then we had 3 plus 2 plus the understood 1, and that gives us a power of k to the sixth. Then we have 2 plus 2, which gives me an exponent of 4. So the product rule simply says when you have bases that are the same and you are multiplying the expression, you simply add your exponents. So on these examples, we're just going to apply the rule. So 8 to the third times 8 to the sixth is really 8, and we are going to add 3 plus 6, and we get 8 to the ninth power. X to the third times x to the eighth is really x to the 3 plus 8, which gives us x to the 11th. Number 7, again, we're going to be careful and we're going to use parentheses because the negative is included. So we have a base of -6 raised to the fifth times -6 raised to the -2. And we get -6 raised to the +3. Our last example of the product rule, I'm going to go ahead and put in my understood 1 here so I don't forget that. So I have a base of y, and it's raised to the -4 times exponent of -2 times y to the first. So here we have -4 plus -2, that's -6, plus 1 gives me -5. Now remember, from our last lesson, we are not going to leave a negative exponent. So to totally simplify this, we need to reciprocate and bring y to the negative fifth to the denominator, and then making our exponent positive 5. Okay, now let's take a look at when we are dividing with powers that are the same base, and let's see what happens here. We're going to expand, so c to the fifth is c times c times c times c times c, divided by c times c times c. Now remember, anytime you have a value or an expression divided by itself, that simply gives us 1. So we can say they kind of cancel. So now what is left is c squared. Number 10, we have 5 times 5 times 5 times 5 divided by 5 squared, which is 5 times 5. Again, you can see these pairs cancel out, leaving us with 5 squared. Again, you may see a pattern developing. Number 11, we have m times m in our numerator, and then m times n times n, m in the denominator. We're going to cancel. So notice here, there is nothing left in our numerator, so we can't leave it empty. So remember, we're going to use a 1 over m to the first, or just m. And our last example here of expanding, 2 times 2 times 2 over 2 to the fifth. So we are going to cancel these pairs, and we're left with 1 over 2 squared. And again, we're not going to evaluate these right now. We're just simplifying. Okay, let's do 4 more examples, and I think you'll have this. So we're just going to simply apply the rule. So here we have a raised to the 7 minus 4. So you see that it's the numerator exponent divided by the exponent in the denominator. So 7 minus 4. That simply gives us a to the third. We have 8 to the fourth divided by 8 squared. So we're going to subtract exponents because our bases are the same and we are dividing. So we're going to be canceling out some 8s. So that gives us 8 squared. We have k, and we're going to have 3 minus 5, which gives us k to the negative 2. But remember, we don't want to leave a negative exponent. We're going to reciprocate k to the negative 2. That clears up our negative exponent, and we're going to put an understood 1 in the numerator. And our last one, we have a base of 2. We are dividing by like powers. So we're going to use the rule, the quotient rule, which says subtract the top minus the bottom. So be very careful with your negatives. So it's negative 3 minus 5, and that gives us 2 to the negative 8. Again, we're going to simplify this negative exponent. We're going to reciprocate and bring the 2 to the negative 8 to the denominator, making it a positive exponent. And again, we're not going to evaluate, we're just simply simplifying. So just remember, the product rule is you add exponents when bases are the same. The quotient rule is you're going to subtract top minus the bottom exponent whenever you have the same bases. Now you try the next few problems, 1 through 21.